Hello, my dear children. Welcome to the mathematics class. Today we are going to discuss quadrilaterals. In this chapter, we are going to discuss the problems in the exercise 8.2, page number 151 in the textbook. In the previous class, we have discussed two questions in this exercise so far. I have given question number 3 and question number 4 as homework. I hope you have done well. Okay, my dear children. Right. Now come to the fifth question. Question number 5. Are you ready to listen the class? Right. In a parallelogram ABCD, E and F are midpoints of sides AB and CD respectively. See the adjacent figure. So, observe this figure, my dear children. Observe this figure, my dear children, carefully. ABCD is a parallelogram. Here, E and F are midpoints of AB and CD respectively. Okay, my dear children, understood? Show that the line segments AF and EC, this line segment AF and this line segment CE, trisect the diagonal BD. We have to show that these two line segments trisect, means divides this line segment BD into three equal parts. Okay, my children, means DP is equal to PQ is equal to QB. It is enough to show that dp is equal to pq is equal to qb. Then automatically we can conclude that these af and ce trisect diagonal bd. Okay, my children, right. Now come to the solution part. First of all, let us write the given data. What is given in a parallelogram abcd? Given in a parallelogram ABCD, E and F are midpoints of sides AB and CD respectively. Okay, my children, this is the given data for us. Since ABCD is a parallelogram, AB is parallel to CD, isn't it or not, my children? Yes or no? This implies AB is parallel to CD and AB is equal to CD. Because in a parallelogram, you know the properties of sides of a parallelogram. Pair of opposite sides of a parallelogram are parallel and equal. Okay, my children. Because pair of opposite sides of a parallelogram, pair of opposite sides of a parallelogram are parallel and equal. Okay, my children, by using this properties of sides of a parallelogram, we wrote this step. Let us consider this is equation 1. Okay, my children, understood this step? Right. Now, AB is equal to CD. Isn't it or not, my children? And moreover, F is also on the line segment CD and E is on the line segment F. Therefore, FC is parallel to AE. Understood this step, my children? FC is parallel to AE. Now AB is equal to CD. from the equation 1, we get AB is equal to CD. Let us divide by 2 on both sides. Okay, my children. So half of AB is equal to half of CD. We are multiplying this equation on both sides by 1 by 2. Okay, my children. Half of AB. What is half of AB? AE. Can we write it or not? Because E is the midpoint of AB. E is the midpoint of AB. So half of AB can be written as AE is equal to half of CD. Here F is the midpoint. We have written F is the midpoint of CD. So half of CD can be written as FC. Okay, my children, understood? Right. So these two, from these two, see here in this quadrilateral FAEC, in this quadrilateral FAEC, let us consider this is 2 and this is 3. So in this quadrilateral FAEC, these two, the pair of opposite sides are parallel and equal. Parallel and equal. Then we can say that this quadrilateral is a parallelogram. Understood this point, my children? Right. Therefore, in the quadrilateral FA, FAEC, 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 FC is parallel to AE, FC is parallel to AE, from the equation 2, FA is parallel to AE and FC is parallel to AE and FC is equal to AE and FC is equal to AE. This is from the equation 3. Understood this step, my children? Right. So in this quadrilateral FAEC, these two sides are parallel and also equal. Then we can say that this quadrilateral FAEC is a parallelogram. Understood this point, my children? Right. Therefore, FAEC is a parallelogram. Because a quadrilateral is a parallelogram if a pair of opposite sides are parallel and equal. So, in a quadrilateral, if a pair of opposite sides are parallel and equal, then the quadrilateral is said to be a parallelogram. That is why we wrote FAEC is a parallelogram. Because in this quadrilateral, AE is parallel to FC and A is equal to FC. We wrote the steps in the previous steps. Okay, my children, understood? Right. Now come to the triangle DQC. DQC. Okay, my children. In triangle DQC, in triangle DQC, in triangle DQC, F is the midpoint of DC. Isn't it, my children? F is midpoint of DC. F is a midpoint of DC. And FP is parallel to QC, isn't it or not, my children? And FP is parallel to QC. FP, this line, is parallel to QC because it is in this point is on the line AF and Q is on the line ACE. So these two sides are parallel. So AP is also parallel to QE and PF is parallel to CQ. Understood this step by this learn? Right. This implies we can say that P is the midpoint of, therefore P is the midpoint of DQ. P is midpoint of DQ by converse of midpoint theorem. The converse of the midpoint theorem says that if a line is in a triangle, if a line is parallel to, one side and one point is a midpoint, then the other end of the point is also midpoint of the side. Okay, my children. So by the converse of the midpoint theorem, we can say that P is also midpoint of DQ. This implies we can say that DP is equal to PQ. Okay, my children. Let us consider this is the result 4. We have proved that DP is equal to PQ. Okay, my children. Understood? Right. Now let us take triangle CQD. Let us take the triangle CQD. Okay, my children. The triangle this is over, CQD is over. Now let us take the triangle BAP. In this triangle, in triangle BAP, here AP is parallel to QE. Okay, my children. And E is the midpoint of AB. E is midpoint of AB. E is midpoint of AB. And EQ is parallel to AP. And EQ is parallel to AP. Therefore, we can say that just like here. Therefore, Q is midpoint of PB. Okay, my children, understood this step, right? So, since Q is a midpoint of PB, PQ is equal to QB. Therefore, this is also by the converse of midpoint theorem. As we have used the concept of converse of midpoint theorem to write this statement, here also to write this step we used the concept of converse of midpoint theorem. Okay, my children, understood? Right. This implies we can say that PQ is equal to QB. PQ is equal to QB. Let us consider this is 5. So from 4 and 5, from 4 and 5, from the equations 4 and 5, we get dp is equal to pq, dp is equal to pq, and pq is equal to qb. So dp is equal to pq and pq is equal to qb. So all these are of equal length. So this line BD, the diagonal BD is trisected by the line segments AF and EC. Therefore, we can say that. Therefore, we can say that the line segments AF and EC trisect the diagonal BD. Hence proved. Understood, my dear children? Right. Now come to the next question, that is question number 6. Show that the line segments joining the midpoints of the opposite sides of a quadrilateral bisect each other. Okay, my dear children, understood this step question? Right. Now let us consider this is a quadrilateral. ABCD is a quadrilateral. In this quadrilateral, let us assume that P, Q, R and S are midpoints of the sides AB, BC, CD and AD respectively. Okay, my children. Now we have to prove that these two lines SQ and PR bisect each other. We have to prove that they bisect each other. Okay, my children, understood this question? Right. Now, first of all, let us write the given data. Given, let ABCD is a quadrilateral. Let ABCD is a quadrilateral. Let P, Q, R and S are the midpoints of the sides AB, BC, CD and DA respectively. Okay, my children, understood this step? We have taken ABCD is a quadrilateral. In this quadrilateral, P, Q, R and S are midpoints of these four sides. Okay, my children, what should be proved? Required to prove P, R and SQ. P, R and SQ bisect each other. They bisect each other. We have to prove that they bisect each other. Okay, my children, understood this step? Right. So to prove this step, to prove this statement, let us draw construction. Join these points. Okay, my children. Join these points. Okay, my children. Construction. Join PQ Join PQ, QR, RS and SP. Okay, my children, got this point. We have joined these 4 points PQ, QR, RS and SP. Okay, my children, right. Now come to this point. We have constructed. Now let us take the diagonal AC. Let us take the diagonal AC. So in this triangle ABC, let us take triangle ABC. Okay, my children. In triangle ABC, P is a midpoint. Isn't it, or not, my children? Or in triangle ADC or ABC, you can take any. So in triangle ABC, these 2 points are midpoints of AB and BC. Isn't it, or not, my children? P and Q are midpoints of AB and BC. Isn't it, or not, my children? Yes or no? So these two midpoints in the triangle ABC, these two are midpoints of these two sides. So by the midpoint theorem, we can say that the line segment PQ is parallel to AC. This implies PQ is parallel to AC and PQ is equal to half of AC. By, let us consider this is result 1 by midpoint theorem. Okay, my children, understood this step? These 2 points are midpoints of AB and BC. We are joining these 2 points. Then this line segment is parallel to AC and half of AC. Okay, my children. Right. Similarly, in triangle ADC, S and R are midpoints of CD and DA respectively. CD and DA respectively. R is the midpoint of CD and S is the midpoint of DA. Okay, my children. So here also we can use the concept of midpoint theorem. This implies RS is parallel to AC and RS is equal to half of AC. Let us consider this is result 2. Okay, my children. This is also by using the concept of midpoint theorem. By applying the concept of midpoint theorem, we got this result. So from 1 and 2, if you take the quadrilateral PQ is parallel to AC, PQ is parallel to AC, RS is also parallel to AC. Then PQ is parallel to RS. Isn't it, or not, my children? Yes or no? Yes. And they are equal. PQ is equal to RS because half of AC, this is also half of AC. Okay, my children. Understood this point? Right. So in this quadrilateral PQRS, in the quadrilateral PQRS, the quadrilateral PQRS, PQ is parallel to AC, PQ is parallel to AC, and PQ is equal to half of AC, and SR is parallel to AC from 1, and SR is equal to half of AC. This is from 2. We have already written these results. So from 1 to 2 we got this one. So in this quadrilateral, this PQ and RS are a pair of opposite sides. Yes or no, my children? These two sides are pair of opposite sides. They are parallel to each other. This implies, what can we say? PQ is parallel to SR and PQ is equal to SR. SR no, my children? This is also of AC, this is also of AC. So PQ is equal to SR and they are parallel to each other. Then we can say that this quadrilateral PQRS is a parallelogram. Therefore, PQRS is a parallelogram. Because a quadrilateral is a parallelogram if a pair of opposite sides are parallel and equal. So by using this property, we say that PQRS is a parallelogram. In this quadrilateral, these two are opposite sides. Yes or no, my children? So these two are parallel sides and these two are parallel to each other. PQ is parallel to SR and PQ is equal to SR. They are equal also. Then we can say that this quadrilateral is a parallelogram. Okay, my children. So with respect to this quadrilateral PQRS, PR and SQ are diagonals. Isn't it or not, my children? They are diagonals of the parallelogram. Here, PR and SQ are diagonals of the parallelogram. With respect to the parallelogram PQRS, this SQ and PR are said to be diagonals of the parallelogram PQRS. Therefore, they bisect each other because what is the diagonals property of a parallelogram? Diagonals of a parallelogram bisect each other. Therefore, PR and SQ bisect each other because diagonals of a parallelogram bisect each other. Okay, my children, by using this property, we say that PR and SQ are bisecting each other. Hence proved. Understood, my children? Right. Now come to the next question. Question number 7. ABC is a triangle, right angle at C. In this triangle at C, right angle is formed. Okay, my children, understood this step? A line through the midpoint M of hypotenuse AB and parallel to BC intersects AC at D. Okay, my children. Show that D is the midpoint of AC. This is the first part of the question. Second part, MD is perpendicular to AC. This is second part of the question. And the third part of the question is CM is equal to MA is equal to half of AB. This is the third part of the question. So we have to prove these three parts one by one. Okay, my children. Right. Now come to the solution part. Let us draw the triangle, a right angle triangle. So we have drawn a right angle triangle. A right angle is formed at point C. Okay, my children. What is given? A line through the midpoint M of hypotenuse AB. Here M is the midpoint of AB. M is the midpoint of AB. And a parallel line is drawn to the BC through this M. A line is parallel to. Okay, my children. It is intersecting AC at D. This parallel line is intersecting the line segment AC at D. Then we have to prove that D is the midpoint of AC. We have to show that D is the midpoint of AC. MD is perpendicular to AC. CM, this line segment CM is equal to MA is equal to half of AB. Okay, my children, understood this diagram, right? Now come to the solution part. Let us write the given data first. In the adjacent figure, given ABC is a triangle. Same we write the same as in the question. Right angled at C. M is a midpoint. M is midpoint. M is midpoint of AB. Hypotenuse, midpoint of hypotenuse. So we can write here AM is equal to MB, AM or MA is equal to MB is equal to half of AB. Okay, my children. MA is equal to MB. This is equal to half of AB. Okay, my children. Right. It is a parallel. DM is a parallel to BC. This is also given. All these lines, all these steps are given in the question itself. Okay, my children. Now we have to prove, required to prove. What is to be proved? First part of the question is D is midpoint. D is midpoint of AC. And second part, what is the second part? MD is perpendicular to AC. And third part, CM is equal to MA is equal to half of AB. We have to prove these three parts. Okay, my children, understood? Right. We prove all these three parts one by one. Okay, my children? Right. Now come to the first part. To prove D is a midpoint of AC. Okay, my children. Right. In triangle ADC, in triangle ADC, what is given? M is a midpoint. M is a midpoint of AB, and DM is parallel to BC. It is given. This implies this is given. This implies we can say that D is the midpoint of AC by the converse of the midpoint theorem. By the converse of the midpoint theorem, because in this triangle M is midpoint and it is parallel to this BC. So what is the converse of the midpoint theorem? If a line is drawn parallel to one side through a midpoint of one side, then it bisects the third side. So by that statement we can say that D is a midpoint of AC. That is proved. First part of the question is over. Now come to the second part. We have to prove that MD is perpendicular to AC. MD is perpendicular to AC. Okay, my children. Here MD is parallel to BC, isn't it or not, my children? MD is parallel to CB or BC. MD is parallel to BC. DM is parallel to BC. It is given already. Given. Angle DCB is equal to 90 degrees. Isn't it or not, my children? Angle DCB is equal to 90 degrees. This is also given. Right angle is formed at point C. So angle DCB is equal to 90 degrees. Then automatically angle ADM, this angle is equal to 90 degrees because corresponding angles. Isn't it or not, my children? For these two parallel lines, AC is transversal, then angle ADM is 90 degrees. Okay, my children. Therefore, angle ADM is equal to 90 degrees because angle ADM and angle DCB are a pair of corresponding angles for the parallel lines DM and BC with AC is transversal. Okay, my children, by using this point, we wrote angle ADM is equal to 90 degrees. Then angle DCB, angle MDC is also 90 degrees. Isn't it or not, my children? Angle MDC because these are alternate interior angles. Isn't it or not, my children? Angle DCB angle DCB, angle MDC plus angle DCB. (180°). Okay, my children. Then, because these two are a pair of alternate interior angles, a pair of interior angles, on the same side of the transversal. Okay, my children, these two angles are a pair of interior angles on the same side of the transversal. But angle DCB is equal to 90 degrees. It is already given. So we substitute that angle. Therefore, angle MDC plus 90 degrees is equal to 180 degrees. Okay, my children, understood? Because angle DCB is 90 degree, we are substituting this 90 degrees in this step. Then we get this step. Understood this step, my children? Right. This implies angle MDC is equal to 180 degrees minus 90 degrees. Okay, my children. We transpose plus 90 degrees to RHS. It becomes minus 90 degrees. Okay, my children. Understood this step? Right. This implies angle MDC is equal to what we will get here? 180 minus 90, 90 degrees. Understood this step, my children? Right. So angle MDC is equal to 90 degrees. Okay, my children. Angle MDC is also 90 degrees. Okay, my children, understood? Right. Now come to the third part of the question. We have to prove that CM is equal to MA is equal to half of AB. Okay, my children. To prove this one, let us take these two right angle triangle MAD. Okay, my children. MCD in triangle MAD and the triangle MCD. In these two triangles. Okay, my children. AD is equal to CD. AD is equal to CD. Because D is the midpoint. D is the midpoint. AC. Midpoint of AC. So AD is equal to CD. Next, angle MDA. Angle MDA is equal to angle MDC. Okay, my children. Both are 90 degrees. MDA is equal to MDC. Next, DM is equal to DM. It is a common side. It is a common side. So, two sides and included angle in this triangle is equal to the two sides and include angle in the third side. So, we can say that these two triangles are congruent. Therefore, triangle MAD is congruent to triangle MCD by SAS, two sides and one angle. By SAS congruence rule, we can say that these two triangles are congruent. Then automatically MC or CM is equal to MA. This implies CM is equal to MA. But MA is half of AB. Previously we have wrote that is equal to half of AB. That is already proved because MA is the midpoint of AB. Hence proved. Okay, my children, because this is by CPCT. by CPCT. By CPCT we wrote this part, but MA is equal to half of AB. We have already proved. Hence proved. Okay, my children, understood? Right.